Well, hello and welcome to another DevNation Live. I see DJ Maddie in the chat, Alexi in the chat as well. Always good to have you guys here again. And I'm hoping we have a lot of fun. I think we are. We're going to basically dig into this thing called GitOps. It is kind of a technique using Git and operational automation. So we're actually going to let Ryan cook. Ryan is our guy, our engineer here at Red Hat, who's been digging into this technology, exploring different open source projects. And of course, he supported us, if you remember, for that Red Hat Summit keynote demonstration. He was the guy holding up those Intel NUCs and the whole OpenShift cluster above his head. If you didn't see that demo, I'd encourage you to go back and check that out. You can always email me and we'll find you the link for it. But right now, I want to dive into this topic. We're going to put Ryan on stage and put him on the spot. So Ryan, over to you.
Thanks, Bar. I'm actually really excited to talk about GitOps. So let me go ahead and share some slides. The good thing is I have more demo than we have slides. So that's definitely good for everyone. So as Bar said, I'm here today to talk about GitOps. In my opinion, this is the most exciting thing that I've seen in the last year. A few years ago, it was Ansible, or that, and around the same time, Kubernetes. This is awesome. So GitOps, it sounds like this crazy concept, but all it really is taking your YAML objects, which you load into Kubernetes, and then you just put them in a Git repository. Really crazy. So the thing that I absolutely love about it is it's seriously just running kubeapply-f over and over and over and over again against the items in your Git repository. So it's not crazy complex, and if you really wanted to, you could dedicate a coworker to be your GitOps tool. But there are some really exciting tools out there. So we're going to actually show one off today. Another thing, when it comes to templating, so you might be deploying your applications among like multiple clusters. So having the ability to use templating, whether it's Helm or Customize, most of these tools accept these templating technologies right out of the gate. And the last thing is with GitOps, there's no object creation limits. So you can do everything from your YAML for authentication, machine sets, or anything that you can think of, you can shove in GitOps. There are some best practices, and it's really good to understand these before you get started. With whatever tool that you choose, it's always, regardless of whether it's GitOps, Kubernetes, SSH systems in general, least privileges as possible. You don't want to give your tool too much access, you don't want to give it too little, but you just want to make sure that it can't impact others and it just stays in a state where it's safe for everyone to use. Store code in your Kubernetes objects in different repositories. The reason why we say that is it becomes kind of cumbersome, and depending on the tool that you're using, your GitOps tool might use webhooks, and if you're just storing some code in there, you might not want to push a build at that time. And just for kind of security reasons, those Kubernetes objects might have secrets involved, might have some routing information. So it's also advised to keep the Kubernetes objects in a private repository. And then lastly, with anything, whether it's application code or GitOps, YAML artifacts, documentation is key. I say that because you don't want your whole entire cluster to go down in the middle of the night and then try to remember how to run GitOps tools or how to deploy your application. So there's two deployment models that I'm actually going to talk about today, and I'm going to kind of highlight a couple products that fall in between these deployment models. So first, you have a hub and spoke. You'll see this with the advanced cluster manager that was showed off at Red Hat Summit. And what hub and spoke really means is that there's a centralized server that's passing out configuration to multiple Kubernetes clusters, OpenShift clusters. This is kind of cool that if you have a hub cluster and you have multiple edge clusters all around the world, all running independently, then you just tell them what to run and you push the code directly to them. But there is a downside of that if your hub does go down, your spokes just kind of run in a static state and can't really be updated until that hub does come online. The other side of that is you have a cluster kind of independent GitOps model, and that is where you have actual GitOps tools running on each and every one of those clusters. You'll see that with Flux, for example. What you can do is you deploy the Flux GitOps tool on each of the clusters, and what it does is it just maintains the state of that cluster and has no awareness of spokes or other clusters. It really just depends on what your architecture looks like, whether you're hybrid cloud or how many clusters you really have when you choose which methodology that you want to use. we're actually going to go with kind of a hub and spoke model. We're going to have Argosy, which is the application that we're going to use for GitOps tool today. And it's going to manage multiple Kubernetes and OpenShift clusters. And as you see here, we load our YAML into Git. Argosy talks to the Git repository and then tells these other clusters what they're supposed to look like. So as I said a minute ago, Argosy, why did we choose it? So the reason why I chose Argosy is I've been very comfortable with it. I've worked with it for the last year and a half, and it's just pretty cool. I mean, it's got a cool web UI. As I said earlier in the beginning of the GitOps, it has really cool templating abilities with Helm and Customize. I'm more of a Customize fan just because that's kind of what I started with rather than using Helm charts. The other thing is it's got really cool sync options. Some tools do not have the ability to do pruning. What pruning is if you have pruning enabled for your GitOps tool, it's going to take and it's just going to delete anything that's actually not in your Git repository. So if you have a security engineer in your organization, they're going to absolutely love pruning because it is that administrator that's saying, no, that's not in Git. Get that off my cluster. There's also autosync. And the really cool thing is with autosync is that once your code passes whatever testing or whatever you have for your Git repository, and then you merge it into that repository, the GitOps tool and Argosy will actually automatically deploy that without you having to do anything at all. And so that autosync is constantly checking in on the code, seeing if there's any updates. And if it does see the update, it's going to deploy it. So the last thing is webhooks. That's something you see with other GitOps tools. Webhooks are just kind of a notification tool that, hey, something's changed. So why don't you go ahead and kick off a deploy for me? And then lastly, as I showed in the last picture, multiple cluster configuration. That's that hub and spoke methodology that I really, really like. So as I said in the last slide, customize. Customize allows you to add override values in your Kubernetes objects. It's integrated directly into kubectl. So if you're running kubectl today, you can have a customized directory and then run kubeapply-k. And that -k lets you know that something in there is customized, and it'll see a customization YAML and deploy this special application specifically for that cluster, that namespace, etc. And like I said, customize is powerful for multi-site. So that's a lot of slides. So go into a demo. I chose the name Stop, Collaborate, and Deploy because I want to go back to the concept of stop modifying things on your cluster in cluster. Those are really hard to replicate. Those are really hard to retain, backup, everything. And then moving those into a Git repository opens the door for collaboration. And then with that Git repository, you have a GitOps tool doing your deploy. So let's look at some code. Let's have some fun.
And here I thought it was more like stop, drop, and roll, like you're on fire.
I was really running track of the stop, collaborate, and listen, but I felt like I was possibly dating myself in regards to how old that song is. All right, so as you see here, we have a OpenShift command line terminal, and I realized that I need to go and show the OpenShift console. So going to our OpenShift console, this is a 4.4 cluster. As you see, it's relatively new. There's nothing really special here. What we're going to do is with this cluster, we're actually going to deploy our Argosy tool, and we're going to actually deploy it with use of an operator. So the really cool thing is about using the operator, we go to Operator Hub, we type in Argosy. All right, give me 1 second. Let me see what happened to the Argosy operator. Nothing like doing it live, right, Burr?
Right.
All right, let me check at another cluster. We might be having some fun with this demo.
And people are enjoying the Vanilla Ice reference, by the way.
Yes, at least some people got it. I love it.
Greg seems to have figured it out really fast.
All right, so I'm actually just going to log into the console of our second cluster. We might actually be using this as our home base. Go ahead and create the project. Project named Argosy again. We'll go to Operator Hub. All project. All right, so the cool thing is I have workarounds that spawn workarounds. So we're going to kick it old school a little bit, and I'm going to not install via the operator. So give me 1 second. I will go into a different repository.
Trying to find something on Operator Hub there?
I'm actually going to install it the old school method of pulling the YAML and installing it. So what I'm going to do is, as you see here with my highlighted text, I'm going to pull the latest stable version of Argosy. And it helps when I'm in the correct namespace. Ready for live demos. Okay, so we're in the Argosy namespace. We're on our East 1 cluster. And as you see, we are creating all sorts of deployments and such for us to use Argosy. So what we actually did was we went ahead, pulled the latest known good version of Argosy, and we told it to install. Right now, we're going to take and do some patching to allow it to run on OpenShift. The reason why I say patching is because we have to allow it to use gRPC. So as you see here with this route right here, we're going to do a redirect, and in a moment, I should have an Argosy route.
In this case, it's the route on the edge cluster.
Right. Well, this is the route for the deployment of Argosy. This will be our kind of our hub cluster.
Okay.
And then we will also have, our spokes that we import here in a moment.
It just said edge there, so that's why I was wondering about it.
It's just how the route is set up. We can actually use this to manage all of our edge nodes and deployments. And so, as you see here, I'm going to go ahead and switch terminals. We have our Argosy UI, web UI. So what I'm going to do now is I turned off the screen so that I can actually get the password. All right, so we're going to go ahead and log in. As you see, we have the latest version of Argosy deployed. So from here, let's make sure that I'm sharing the right thing. Yep. All right, so let's have some fun with this. All right, so what we need to actually do is we need to import a repository, and then we need to add some clusters to the environment. So what we're going to actually do is we're going to go back to our command line. Sorry if I made this very confusing, but how live demos go. Okay, so we have Argosy installed. We have logged into the cluster. We're going to use the Argo binary to actually allow us to load a private repository. The reason why we have to use the binary is because we're loading a private repository which requires an SSH private key. And so now when we go back to our Argosy tool, we know that we have this repository available. So the next thing we're going to do is we're going to add some clusters. And this is the cluster add is based off the context within my kube config. So if I do OC config get context, as you see here, we have a West 2 We have an east2 and an east1. So we're going to go to cd cluster add 1. We're going to add east2 and west2. What this means is, going back to our diagram that we had earlier, these are all of our spoke clusters that we're going to actually deploy our applications to. So now that we have that complete, let's deploy authentication. So the main thing to think of is that we can do this manually. We can deploy authentication to our one cluster. But the problem is that doesn't scale really well at all. So this is the Git repository that we loaded earlier. The really cool thing is that when we specify the repository, Argosy has the ability to look at the directories within the repository, and we can see that our east1 cluster is here to apply authentication to. So if we go ahead and click this and select our cluster of east1,
are you in the right screen?
I am probably not. Let's see here. Oh no, okay. All right, let me start back over. All right,
yeah, there we go.
So what we're going to do is we're going to create a new Argosy application. It's going to be our authentication for our east1 cluster. And we're going to automatically apply any configuration changes as they come in. And we're also going to prune resources, so that way if a rogue admin is added to our box, that rogue admin is going to be completely removed. So let's go ahead and create this. And we're going to place the configuration of the Argosy application within the OpenShift config namespace. So give it a second to refresh. And as you see, we have added authentication to GitHub for our east1 cluster. So what does that honestly mean? So what we actually did was we supplied a GitHub secret and a GitHub ID to be able to actually log into this cluster using GitHub credentials. And the really cool thing is, as well, is that I can actually manage all of my administrators through this file. And so that's, as I said earlier, that's cool if you want to do it on one cluster. I can do that, in minutes. But what about when you go multi-cluster? So we'll do authentication, West2, and the default Argo project. We're going to prune and self-heal again. Use our same DevNation Git repository, which will be available after the call. And we're going to do authentication for West2. We're going to apply this on West2 and OpenShift config. So we're going to create that. And so this will sync within a few moments. And here we go. As you see, out of sync, we're going to have my cluster admin of Cook the Ryan being able to administrate clusters. But, this doesn't really scale. This doesn't do anything really fancy, whatever. So let's show how we can modify multiple clusters at the same exact time. So going back to our command line, we're going to go over to here, and we have our Git repository. So if we go into authentication with this, what we actually applied, you'll see these two directories called base and overlays. This is through the use of customize that we're allowed to add specific values to each individual cluster. So what we're going to do is we're going to modify the base. And what base actually means is that's common YAML files that need to be laid down on all of the clusters regardless of what their values are. What we're going to do is we're going to add an extra administrator in. We're going to make this the administrator 1. And I'm going to add in the admin of Bert Sutter. Congratulations, Burr. You have yet another job. You get to be the administrator of all of these clusters. So go ahead and git commit this.
Now,
All
one
right.
thing I will just call out because I think it's super interesting about the Argo CD architecture. It's basically a reconciliation loop, looking back at that Git repo, seeing that things have changed, and applying a diff, right? It's essentially doing a diff to see what changed and deciding what to do with that. Is that a way to articulate it?
That's exactly it. Because as you see here, when we hit the sync button, it's going to see what we actually have running, and it's going to find out what the difference is, and it's going to actually apply that. And based off of our commit tag of F1D7973, it realized that there was a change. So we have now added you, Burr, as an administrator of our West cluster and our East cluster. I'm forcing the sync because, due to timeliness.
Right.
But now, Burr, you can be a cluster admin of both these clusters at the same exact time. And this makes it really cool because of the fact that if I need to make modifications to multiple clusters, add new engineers, remove engineers, I can do it very, very fast and all at the same time.
One thing I noticed too and I hope you don't mind me interrupting, but one thing I noticed in the user interface is it defaulted to manual and not to prune. And that's kind of surprising to me. Do you know why, or can you give some examples as to when you would not prune or you want a fully manual experience?
A lot of people are still kind of skeptical of prune just because of the fact that they might be using it as a test environment, a dev environment, and if you prune something that you're just coding in that namespace, you might lose everything. So if you're using it as a development cluster, but almost in the same way that you would catch up your master branch, at some point you want to do that manual sync to the repository just so that you know you're running clean. Just as kind of like a hard reset, like a git reset just for that namespace. So that's one of the scenarios that I could see that happening.
Makes sense.
So what about like the brownfield? So you're on this call, you're like, okay, well, I already have all my applications deployed. I can't use Argo CD. I can't bring back in my objects. I don't want to start from scratch again. The good thing is we have you covered. So when we go and we have an application called Simple App. Deployment, go to deployment, it's got service, it's got routes, it's got all of our standard values that we would expect for a project. And so what we can actually do is we can take all of this YAML out, put it in a Git repository, and then be GitOpsing. So what I'm going to do is I'm actually going to take and first pull in the deployment. I'm going to make a directory within my Git repository. We're going to call it letters because if you go, so if you're on your application, if you're on watching this broadcast right now and you go to this, you'll see the letter of the day. I have a little toddler, and so we have letter of the day. As you see today, when you go to this URL, the letter of the day is S, I believe. And so let's take and suck up this application into GitOps so that way I can just use merge requests anytime that the letter of the day changes. So I'm going to take the deployment of our simple application. And so I did an OC deployment -o YAML, and then I exported the deployment into a deployment YAML. So if you see it here, it's our standard deployment config. I'm going to take and load in our config map, our service, and our route. So going back to our Argo CD web UI again, we're going to create a new application. It's going to be our simple app. And I like the sync policy manual and prune and self-heal. I'll show you why I like the self-heal momentarily. And then from here, I will do letters for the letter of the day application. We're going to place it back on East 1, and we're going to put it in the simple app namespace. So create it. It's out of sync, and we are already deploying the same application, same letter of the day. And we go here, we see that we have our routes yet again. I like this. Make sure my pod is running. It is. And we see that S is still the letter of the day. So the one thing that I want to show about the self-healing thing is, and it's the fact that with Argo CD, you have an administrator working on your application 24 hours a day, 7 days a week. So I'm going to actually take and I'm going to delete the deployment. I'm going to delete the service. And as you see, I was actually going to try to delete the namespace, and Argo CD moves faster at remediating the problem than I do of me deleting everything. So it's that extra administrator working at 3 in the morning, making sure that your application is still there and that user error doesn't exist, or at least it's limited a bit. So if I have time, I am going to try to squeeze out a really fun application and show how this whole thing can fit in your development lifecycle of going from a testing branch into production. So we are in repository still. We're going to go ahead and check out a new application called Game. So we have our application, and as you see, go into the Game application itself. It contains deployment. It also has some customization.
Are you sharing?
And
And there was a question about self-heal also. When you saw things get corrected, was that the self-healing aspect of it?
Yep, that is exactly the self-healing aspect. That's why I always make sure to check that checkbox.
Okay.
And so, okay, hopefully I'm sharing my terminal now. Sorry about that.
Yep.
And as you see here, we have that same base and customized format that we saw earlier. We have all of our Pacman application items, but the cool thing is we also have these overlays. And what we need to do with our overlays is that we want to deploy the testing portion of this application on one of the same clusters that we're actually going to deploy prod. So we need to make some changes to this, but we don't want to modify the production-based application. So as you see here, we're going to use customize. We're going to change the namespace to game testing. And then we also need to modify the role binding, the namespace, and the cluster role. So let's go ahead and I'm going to say the game. I didn't have any code in there. So, all right, what we're going to do now is we're going to load our testing variation of the game into Argo CD as our last item of the day. I wish I had more time and we would have showed moving up the production ladder. But so we love game. We're going to actually automatically sync it. We're going to self-heal and prune. And for our revision is this time it's going to be game. That is our game repository code. And we're going to select testing, cluster of East 1, and the namespace of Argo CD. We're going to place that in the Argo CD so that I can delete the application later. The namespace when it comes to this is only dependent on where the application of Argo CD is deployed. So as you see here, our changes that we applied within our customization of trying to find name, sorry, did not apply. Okay, I must have selected the wrong directory, and I have ran out of time as well. So as you see here, we have a really cool game. If you go to game testing here, it is a full game for us to play. The thing is, what I want to really show is that you can make modifications in this namespace, in this branch, merge that production, and then have the same base code for your application be used regardless if it's a testing environment or if it's your production environment, all through the use of customize. And I really apologize for running out of time on that.
Well, I know people were enjoying the 80s references, so the Pac-Man thing could have been fun for us. But I did want to ask you a couple questions, and there might be some more questions that pop in. So we have a couple more minutes if we could take a few more of your minutes of your time there, Ryan. And one is, I noticed that you were exporting the YAML from live objects to basically put them in the Git repo to become the Argo CD object. So like a deployment, a route, a service. Now sometimes you sometimes have to modify or tweak that YAML that comes out of a live object to move into a repository. So can you give us more information on that? And you also mentioned machine sets, and I'm curious to know how you would manage those also.
Okay, so what we'll do is we'll first start with modifying the objects that we export. So for some reason, Argosy itself kind of obsesses over certain items, and it feels like they're out of sync at all times. And that is because the Argosy code itself has written functionality in to just ignore those. But if you provide a value, then it's like, I don't know how to compute this. And so you'll see situations where it says the application's out of sync, but it is still in sync, and it's just complaining about something that's not actually relevant. And then as for your machine sets, so the cool thing with that would be we would actually follow the same exact flow that we did for exporting our simple application. We would take and export our machine set, and from there just load it into Git and specify that our OpenShift machine config namespace when we load it into Argosy. And then from there we can actually use Git to modify the replicas, like how many nodes that we have. And the really fun thing with that is that it's in Git. We can modify it in one place and just be done. It's saved in Git. We had that location to see, oh, it was Burr that added 10 nodes to our AWS cluster, and
right.
You have that tracking, and it's really cool to have that audit and that tracking feature.
Or change the instance type, so it went from a little 8-core machine to a 64-core machine, as an example.
Exactly, and so it's that two-sided thing. You have that the audit trail a little bit with your Git log, and then you also just have it in a safe place just in case anything happens with it. If you're modifying this information on the fly on the systems, and you mess up a deployment config or you lose a variable or whatever, you have to hope that it's saved somewhere, or you're in a really tough spot.
Okay. Well, we are out of time, but I want to thank James and Greg and DJ Maddie. Right, they had some real fun with the 70s and 80s references there. We had some nice conversation. People were wondering if your password was password, by the way, when you put that in earlier, or maybe admin. We were trying to guess if it was admin or password. But overall, I love what you said about what you showed us there with GitOps. Right, we have everything in Git. So we have the audit trail, we have who did what, we have the ability to do a blameless postmortem, because we kind of know what happened in many cases. And so I love that. And also for anybody who is worried about their security position, right, they know exactly how that cluster came to be, how the cluster is configured, what operators it's running, what applications are deployed to it, how are they deployed, with the right secrets, with the right config maps. So all that is incredibly powerful, and I think that's actually very cool from a way to manage your Kubernetes clusters, your OpenShift clusters at scales. So hopefully everyone here has already had our OpenShift admins and operations course, where you learned about machine sets as an example. But this kind of is a nice advanced technique to go over and above the basic install. Ryan, thank you so much. Awesome stuff.
Thanks, Burr. And then if you guys want to see the code, feel free to tweet or email me, CookTheRyan, on everything.
Very good point. I did put Ryan's Twitter handle in the chat earlier. Hopefully you guys have that. I won't post the Vanilla Ice lyrics that I was looking up, because I just thought that was pretty funny. But actually, let me add one more. I'll just add one more tweet to the chat, so you guys you'll see his Twitter handle on it. And then, of course, the get her done joke that I was making on Twitter, which I thought was funny. But Ryan, awesome stuff. Thank you so much. I love the demonstration. It's going to be very powerful for all our audience here. And we hope to see you again in the future. Come up with a new idea and bring it back to DevNation for us.
Definitely will, Burr. Thank you so much.
Thank you. Bye now.